Good morning, students. Welcome back to the fifth session of Is Matter Around Us Pure. In the last sessions, we have discussed about some of the separating techniques. So the left out separating techniques we will discuss today. Okay. In the last sessions, we have discussed about evaporation, the sublimation process. Then we have discussed about separating funnel process. So today we will discuss of separating. How can we separating colors in a dye. Okay. Dye means what? What is a dye? A dye is a component or it is a compound which consists of two or more colors. Okay, that is a dye. Dye means say for example green dye, red dye. You have seen the dyes. Some people dye their hair. So whenever there is color in the hair, then we can call it as they are dyeing the hair. That is, they are using colors to transform the black color of the hair to some other colors. You can see red color, green color, this type of hairs you can see. So what is a dye? A dye is a compound. A dye is a compound in which there is two or more colors present. Okay, it is a dye. Now how can we separate colors in a dye? Because the dye consists of more than two colors, so we have to separate the different colors present in a dye. So there is a technique called chromatography technique. One topic it is given in your book is the dye in black ink a single color. One topic it is there. From that topic I am deriving this topic, that is separating color in a dye. I am repeating again, is black ink a single color? From that topic I have derived this separation technique. Okay. Now one process is there. That process, the name of this process is known as chromatography. Chromatography, it is a technique. Okay, it is a technique in which one of the solvent or the component of present in a dye is soluble in a solvent, particular solvent, and with due to the solvation of the component of the dye in the solvent, there is separation of the colors. That process it is known as chromatography. For chromatography I have to practically show you how to separate color, but how to separate I will draw a diagram. From that you can differentiate. Okay, now you see, for example, one activity it is given in your book. One activity is there. You can say filter paper. I have taken a filter paper. Okay, a filter paper it is taken, and I am taking, say for example, I am taking black ink or blue inks. One of the ink I am taking, and that ink it is soluble in water, because I will take our solvent, that is water solvent. I am different kinds of solvents are there: alcohol, benzene, then butane. This type of different kinds of solvents are there, but since easily available solvent, universal solvent, water I am taking. Okay, and the ink that I am taking, that ink should be soluble in water. Okay, now a filter paper is taken, and in the bottom part of the filter paper a thin line is drawn with the help of a pencil. Okay, one line is drawn at the bottom of the filter paper, and another it is taken it is drawn at the top of the filter paper. Is it clear? Now you see, I am putting, this is the line. Okay, have you seen slides? Slides means this type of glass slides are present in the lab. You can see these are in the shape of the slides only. I am taking a filter paper, piece of filter paper is taken. Okay, now at the lower part of the filter paper a thin line is drawn, and at the upper part of the filter paper I have drawn another line. Now what I am doing, I am putting a spot with the help of, say for example, this is black ink. I am, with the help of this this marker, I am putting a spot in here at the lower line of the filter paper. Now since this black color, this black ink, it can be dissolved in water. So I am taking the solvent, that is in another beaker I am taking say for example, in this beaker I am taking water. Okay, I am taking water. Now what I will do, I will put this filter paper in the beaker. Is it clear? So the diagram it will be in this way. I'm putting this filter paper in the beaker which is containing in which there is water. Okay, now I'm putting this filter paper in this way that the line that I have drawn at the lower part, thus that line is dipped up to that line it is, or below that line I have dipped the filter paper in the beaker containing water. Is it clear? What I am doing, I am putting the filter paper in such a way that the line does not get dissolved, line does not get dipped in the beaker. Okay, now slowly, we know that filter paper always soak water, so it will start absorbing the water, and since this this ink, it is soluble in water, therefore what will happen, this spot that I am giving with this spot will be carried away by the water, because the ink because the dye or the ink that I am taking, that ink it dissolves in water, so the water will now rise up in the filter paper. It will slowly rise up in the filter paper because the filter paper always absorbs light. Now after some time you can see that this spot is also moving, and the original position of this spot is, say for example, this position is original position. A is the original position. A, this is the original position of the spot. Now gradually you can see that this spot, it is disappearing from this line, and because the water it is soaked by the filter paper, and with the help of the water, this spot it is carried away in the filter paper. Now you can see, say for example, one spot is here and another spot is here. Okay, there are two spots now after and whenever the water rises up to this mark, this line, up to this line, this is the final position. C is the final position. Okay, now after some time you can see that whenever the water is absorbed till this line, then we will remove the filter paper from the water. Now distinctly you can find out, you have to consider, okay, this is an example, you can see distinctly two spots in the filter paper. These two spots, it is another color, one of the color, say for example in the black, the black dye that I am using here, one color is blue color and another is the black color. Okay, now here you can see that one spot is present here and another spot is present here, because so distinctly you can find the two colors of the dye, it is present in different position in the filter paper. From here what we can find out, that the particles or the component of the dye or the color in the dye which is more soluble in the water, it is carried away faster and it is present above, and the less soluble it is present below. So we can separate it now. Whenever we will require, the required color can be cut out from this filter paper in this way, and we can separate the different colors present in the dye. So this is how we can separate colors in a dye. Okay, say for example red dye, in the red dye brown color and orange color it is present. I'm just giving an example. Okay, whenever you, while doing coloring watercolor, the students who do art, so art, okay, drawing, while drawing or painting, you use different mixtures of color. So to make say for example the violet color, if you don't have your violet color, there is purple color, or you don't have purple color, say for example you don't have purple color, so how to make purple color? You can mix violet and little bit orange, yellow color, then the color will be slightly purple. So you are mixing violet dye and yellow dye to make the color. Then how can we separate these two colors from the dye? We can separate by the process of chromatography. Chromatography is a technique in which the components of a mixture can be separated with the help of a soluble substance, in which one of the component is carried away and another component is slightly less carried away by the solvent. So this is the technique of separation of colors in a dye. I think it is clear, and this chromatography technique, it is used for separating colors in a dye. Then the from the natural sources. Say for example indigo color. Indigo color can be separated by the process of chromatography. Okay, then these things are given in your book applications part. You see, one is colors in a dye, the separation of colors in a dye. Then secondly, pigments from natural resources, and another example, another application, it is drugs from the blood. The blood, so whenever the bloodstream is coated with drugs, say for example whenever we will take some painkillers or something else, so this can be separated from the blood by the process of chromatography. You can write the definition of chromatography in this way. The technique of separation of components of a mixture. The technique of separation of components of a mixture, that is colors in a dye, by the use of a soluble solvent, it is known as chromatography. Now what is the main principle of chromatography? That is, the more soluble substances are carried away faster with the help of the solvent. So this is the main principle. I am repeating again, more soluble in water, more soluble substances in water rises up, or you can write in this way, rises up faster than the less soluble substance. So this is the main principle of chromatography. I think it is clear. Now we will go to the next topic, separating separating two immiscible liquids. In the last session we have discussed about separating two miscible liquids, but here it is immiscible liquids. Oh, sorry. In the last chapter, immiscible liquids we have discussed. Today we will discuss about miscible liquids. Okay, that is, say for example, in the last session we have discussed about oil and water. Now today we will discuss about some liquids which are already mixed. That is, they are mixed. We know that there are two types of, say for example, alcohol and water. They two mix up easily. So how we will separate these two type of miscible liquids? Separating miscible liquids, two miscible liquids or more than two also we can separate. Two or more, you can write two or more miscible liquids by the process of fractional distillation. Okay, fractional distillation. By the process of fractional distillation. In this process, what happens in the fractional distillation process? It is used for separating the liquids which have a difference of boiling point by 25 degrees centigrade or by 25 Kelvin. There is a separation of the boiling point. That is, by 25 degrees centigrade the boiling point is different from one liquid to another. So that type of liquids can be, miscible liquids can be separated by the process of fractional distillation. What happens here? You see, this process is mainly used in petrochemical industries like petroleum crude oil that is derived from the earth crust. It is separated like petrol, diesel, kerosene, gas, wax. These things are separated by the process of fractional distillation. Crude oil, here in the crude oil we know that petroleum, petrol, then diesel, these are present. They are present in a miscible way. So how can we separate? By the process of fractional distillation. Here you see what happens here. Fractional distillation, see the diagram that is given in your book with the condenser. I am not drawing that. I will show just a fractional distillation column where we can separate the miscible liquids. example, this is a fractional distillation column, because with the diagram that is given in your book, that is the with the condenser, it will take too much time, and I'm not a very good drawing person. Okay, so I am using the easiest way, that is the fractional distillation column I am using. Now you see what happens in a fractional distillation column. Here, this is, say for example, this is a fractional distillation column. This is a rough diagram, okay, schematic diagram for fractional distillation column. Here here you say this is the crude oil present here. This is the crude oil. Okay, this crude oil. Now you see what happens to the fractional distillation column, heat is provided. Now with the help of, whenever heat is provided, because here more than two liquids are present, miscible liquids are present. Now with the help of the heat, what happens, I am telling you that fractional distillation can only be used where the liquids have a boiling point difference of 25 Kelvin or 25 degrees centigrade. Okay, now whenever heat is provided here, the crude oil with the low boiling point, with the rise of temperature, the liquid from here, it will get started. Boiling points boiling means what? They will convert from liquid to gaseous state. So whenever there is heat, the liquid present in the crude oil, they will start means they will get converted from liquid state to gaseous state. Now with the liquid with less boiling point, they will first vaporize. So what happens, they will go slightly with the rise in temperature. Say for example, they are going here, and here these plates are known as the condenser plate. Okay, here what happens, they will get deposited here in the condenser. Okay, because with the rise of temperature, they will get started, they will be converted to gaseous state. Now here, this condenser means what? In condensation process, what happens, the gaseous substance get converted into liquid substance, liquid state, or gaseous substance get converted into liquid state. The process is known as the condensation, and the condenser is the technique where this condensation process takes place. Now it will be deposited here. Now here you can see one outlet is present in everywhere. Okay, so the less or more volatile compounds are collected in the first plate. Then the temperature here, one component A, it is, say for example, in the crude oil, these things are present. Okay, petrol in the crude oil, gasoline is present, then diesel is present, then kerosene is present, then wax, these things are present. Now you see here, gasoline has the lowest boiling point, so it will first vaporize. Then in the second plate, diesel. So diesel have more boiling point, a slightly higher boiling point than gasoline, so they will get vaporized lately than gasoline. So they will get condensed in the second plate. Next here in this plate, you say for example, kerosene it is present. Okay, through this plate, these are the outlet through which this gasoline, diesel, kerosene is collected. Okay, now you see in the last, say for example, wax, asphalt, shoe polish. From the shoe polish is made from asphalt. Okay, and then these things have higher boiling points, so they will be present in the lower position of the fractional distillation column. So this is how miscible liquids are separated from each other with the help of a fractional distillation column, and the boiling point difference is 25 degrees centigrade or 25 Kelvin. So this is the process of fractional distillation. Okay, next this question might come, what is fractional distillation? Fractional distillation is the process or the technique in which miscible liquids are separated which have a boiling point difference of 25 degrees centigrade or 25 Kelvin. This is the definition for fractional distillation. Okay, next, and the last separating technique that I will teach you today will be how we can obtaining Now we know that air is a homogeneous mixture of two or more gases, because in the air we know oxygen, carbon dioxide, then oxygen, carbon dioxide, nitrogen, chlorine, these things are present. The various kinds of then ethane, methane, propane, carbon monoxide, these things are present in the air. More polluted air means more carbon dioxide or carbon monoxide. Now from air we have to separate out, or we have to obtain this, say for example I want to obtain oxygen from the air. So how can we obtain different gases from air? In this process also fractional distillation it is used. First thing, what in the first step what we have to do to obtain the gases from the air, one technique it is present in the last chapter one, that we can compress carbon dioxide. Their gases can be compressed. Okay, they are one example it is there, this fire extinguisher. In the fire extinguisher we use dry ice, that is dry carbon dioxide. Okay, what happens in the carbon dioxide? This carbon dioxide is compressed in a high pressure cylinder. Okay, here you see what happens. How can we obtain the gases from the air? In the first step, gases are liquefied under high pressure. What happens here? In the first step, gases are liquefied under high pressure. With the help of high pressure, we are liquefying the gases present in the air. Now, whenever these gases are liquefied, that is, they will be converted from gaseous state to liquid state. Now, whenever it will be converted into liquefied, that is, whenever it is converted into liquid state, we can use the process of fractional distillation process. Fractional distillation. Then fractional distillation is used for obtaining the gases. Okay, fractional distillation process I have already discussed. Fractional distillation is the process or the technique in which the liquid can be separated with the help of the difference in their boiling point. Okay, so this is the process of fractional distillation, and we can use fractional distillation process for the separation or obtaining gases from air. First, the gases are liquefied under high pressure. You can take the example of carbon dioxide. Carbon dioxide can be converted into liquid state. Oxygen can also be converted into liquid state by the process of by applying high pressure. Now, whenever they are liquefied or they are converted into liquid state, then what happens? So we can use the fractional distillation process, from where we can separate out, because of the difference in their boiling point, we can separate out the gases. Okay. Then one more topic it is there. Obtaining pure copper sulfate from impure solvent. Here the process of crystallization it is used. Crystallization. Now, say for example copper sulfate, it is mixed up with salt. Okay, copper sulfate it is mixed up with some impure salt. Say for example copper sulfate and sodium chloride is present in the say for example sodium chloride is the impurity, and we want to obtain the copper sulfate from the impurity, that is sodium chloride. Now what happens? This sodium chloride and copper sulfate, or the salts, you can take it, you can call it as a salt also. Okay, now we have to obtain copper sulfate from the impure salt. What happens? What we will do, we will dissolve the copper sulfate or the impurities, copper sulfate along with the impurities in a solvent. Now this solvent, we will take such a solvent in which the impurity will dissolve. Okay, the copper sulfate cannot be dissolved. Here say for example I am taking alcohol. Okay, with the help of alcohol, what happens? copper sulfate and the impurities both are dissolved in that solvent. Now we will start heating. With the help of the heat, what happens? The solvent along with the impurities is carried away, or it is converted into vapor or gas. Now what we can see, that we can see fine crystals of copper sulfate present in the vessel or present in the apparatus in which we have heated the mixture. Okay, so this process in which fine crystals will be present, copper sulfate, the fine crystals of copper sulfate will be present in the apparatus where we have heated. So this process is known as crystallization process. That is, the crystallization process is the process in which the pure substances or pure solids are obtained in the form of crystals. This is known as crystallization process. Is it clear? I am telling again, what is how can we obtain? We are taking the mixture in a solvent, particular solvent, and this solvent is heated, and whenever it is heated, we can see that the impurities, they will be carried away, or they will be converted into vapor state. And or we can also see this thing also, that the impurities get dissolved in the solvent, but copper sulfate, it is not getting dissolved in the solvent. Now what we will do, we will heat more, we will apply more heat, then these impurities are carried away with the solvent and it is converted into gaseous state, or in the it is vaporized. Then we can find fine crystals of copper sulfate in the apparatus where we have applied heat, and this is how copper sulfate is obtained from impure salts by the process of crystallization. And then the definition you can write: the process in which pure solids in the form of crystals are obtained from a solution, it is known as crystallization process. It is used for separating salts from a impure mixture. So I will conclude here today. In the next session we will discuss about physical chains and chemical chains, and elements and compounds. Thank you.